Alright. Alright, Loki, don't feel like doing this shit, but whatever. Can't be just rotting. So, giving a string containing just the characters, let's see, closing, opening and closing parentheses, opening, closing curly braces, and opening, closing square brackets determine if the input string is valid. An input string is valid, so as a whole, open brackets and closing. Open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket at the same time. So there's three conditions we have to check, which are very specifically named. And we are to return a boolean. So this is true because it falls off. This is false because it's not closed by the same type of bracket, nor is it in the same order. Okay, I understand. So if we clarify that the constraints is a specific length, constraints of parentheses only. Okay, so we know that the input won't be anything out of the blue, something we wouldn't expect. We know for sure that the input would be, it'd be one of these parentheses. So we don't have to consider an edge case, any edge cases or scenarios where the input would be something funky. Therefore, what this function needs to do is simply test if these three conditions are valid and return true or false. And how we can do that is through a stacked data structure. The reason why we would use a stacked data structure is primarily because of its O1 lookup time. So how we would use a stacked data structure, and this is the flow of logic, I think. So for sure we'd have to loop through. We have to loop into input S. You use a stacked data structure, let's see, particularly because of the nature of how it appends and pops inputs. Because the stacked data structure follows a last in first in last out principle. This means in a scenario where, let's say, we have many let's see, there you go. So this would be like a possible input, right? And this would be a scenario, and the reason why the stacked data structure compared to other data structures, like let's say a queue, would be advantageous because the order it would be popped, it would be appended, would be the same order that it'd be popped. Would follow the corresponding order if it was popped. So, for example, let's say we add all these into the stack, right? We start with parentheses, curly brace. This gets entered into the stack, and then when we pop, and as we're iterating through, the closed parentheses, because we know for sure if we're following at least this is order, closed parentheses will be first in the input. Therefore, we know that whatever is at the top of the stack should be the closed version of the L value that we're at. So for example, let's say we have this input right here. This is appended into the stack. Therefore, this open parentheses is at the top, meaning that if we popped an element from the stack, it would be this open parentheses. The next one would be here. We would append it to the stack. Now, once we get to a closed parentheses, because it has to be in correspondence with the open bracket of the same type, and they must be closed in the correct order and by the same type of bracket, it means that the top bracket of the stack, the top closing, okay, let me restart. I get it from scratch. Okay, so essentially, you want to use a stack data structure, and we want to loop through the input S, then append all closed brackets into the stack. And we do this because once the stack is created and once the stack is created and we reach the first closing parentheses, the first closing character, let's say, each closing character must be the matching closing pair of the opening pair. So you can see we can see this play through. Append this to the stack. We would append this first opening parentheses into the stack. Oh, we see a closing parentheses. This means that we have to check the top of the stack. The top of the stack would be this opening parentheses. Therefore, it satisfies all three of these conditions. Let's go to another example. Let's say this one. So we would first append these into the stack. Therefore, by the time we reach this third index, or this third element, the top of the stack will contain this opening bracket. If we compare this current element, the first closing or the current closing character that we're on, with the top of the stack, they should correspond and match and be the same. And the reason why this works is because I can explain it through an example. Say this was because it follows this logic where every parentheses is perfectly scoped with one another and paired, and they have to be matching. So it must be the matching closing pair of the opening character. Okay. And then within it, we can include an if statement that returns false if the bracket isn't matching. Outside of this loop, we would actually what we could do instead is return true if the stack is empty, because that means every character has a pair. And we can return false if the stack have at least one entry. So first things first. And two ways we could implement a stack is typically through a dynamic array or a linked list, but because we're using Python, it's much more easier. But also, I prefer the dynamic array. Okay, so we could use a dynamic array or a linked list, but let's implement this using a dynamic array because we are using Python. So let's use a dynamic array to represent the stack data structure. So we are going to say, we're going to call this closed. And now let's create a loop. So for character in S, we want to if so if it's any of these close or opening brackets, then append it. All right. And I want to if now this is another check that checks if that checks if it's a closed bracket. Then each code must be the matching closing pair of the opening character. And okay, which must be the matching closing pair. Okay, now that indicates to us. Okay, let's check our stack. Um, so it seems like we'll have to pop. So we're gonna pop the top of the stack, the C, store it in this variable top of stack. Now we're gonna check if top of stack. But how now we run into a problem as we're going through. As we're going through. The list. I think there's a problem with this nested logic. I think what I have to do is just make a bunch of if statements here. But I have a feeling that looks pretty ugly. But I don't know how else I could go about it. Uh, a hash map. We could use a hash map. Okay, well let me just try my little dumb little solution and then we'll try a hash map. Well, my solution would mean so we're gonna have to go one by one. Okay, that was like the dumbest loop I've ever seen in my life. Whatever. A hash map makes sense because we know for sure. Okay. Okay, so If top of stack is equal to the opening parentheses, then yeah, this shit looks so dumb, but whatever, man. It is how I naturally solved it. I'm gonna show you how good I am at why. If top of stack matches, then keep it popped. Okay, we can just keep it popped, but or if it is not equal, it has to be that opening one. Then pop it back in. String cannot object can be interpreted as an integer. Line 29. Can we pop an integer? Oh, we use pop. We're trying to pop is not equal. A pop has to be index or nothing. It only takes one parameter. It needs to be index and an integer, it looks like. So it works. I expected it to work, but I should just like what would be the time complexity of this code? Oh, yeah. Is compares. To make perfect sense. What the? Because it doesn't go over this for that. Oh my god. So if close is empty, then it would be false. Where close is contained. Pop from empty list. First of all, I guess we could put if s use like a base case. Index error. Oh, it's gonna pop up in this. How would we logically? I'm just being hard headed. I just want to try it at this point. But like I'm aware if we use a hash map, that's just pretty straightforward. I just want to see if I can roll. Ah, so this is occurring because in the test case scenario, there's only a closed parentheses. We're trying to pop from an empty list. Mm. Oh, you're using that. If close -1. No, but it already different. This only executes if we don't have to do this. Do all this like a space. We get condition that close -1. So instead of allocating space for like this extra variable, what if we do this text on the spot? I completely forgot. Okay. So now since we can specifically check if it matches the corresponding open one, we could just simply pop it. So pop that top. Pop that top. Okay. So now we have to fix up the logic and the condition. Now it cannot be or or it cannot be any of these close ones for the edge case that needs to be going wrong because we append it. Sure, once we've appended it, we reach here. And oh, seeing how okay, let's just go fucking one line, bro. So if not S2, then so once we start, we will go through this for loop. You'll see what the character here is, so we would append to the same. Great. Um, I guess it does. It goes to every condition. None of them would even execute anyways. And then the second parentheses, okay, sees that, sees clearly that, and the top, so this would never execute at all. Because the top, wait, this would execute. And then if, hmm, why would, okay, I don't know. Time to call backup. Bro, it's embarrassing. I think it's solve a simple fucking stack problem, dude. Whatever. Dude, what? Mm, interesting. I learned that today. So if we're going to use a dictionary, what are we trying to look up? We wouldn't be using the open to look up the close. We use the closings. This is because it's open. This logic is more so going to be used once we start checking, validating the correspondence of the characters. Um, let's see. Proceedings. Logic. Loop through. That would, I would guess that's still a lot. Okay, so we have to do two things. And when open, and also there's an open character, and then check dictionary and close. Then I want to check the dictionary when it's closed and pop it. Turn through if if um, okay, so pen, if there's stack if okay, we can also just include the edge case where stack is empty. Here, top If C is in pairs, then sure that okay, we found that a closed bracket here is identified, but this line of code should check. This should. Mm, we have to check if the top is equal to the key. We need the key. We need C here to access the key. Check if there's a match. Then we want to do pairs. No, what are we doing? We're gonna pop. Well, let's think this through. So weird. But if we append every single character, say we get a scenario where it's only one closed bracket, then we would end up appending that. This would also append whether it's open or closed. Check dictionary. So who does it? That's not true. It should be. The problem. So the problem is it appends indiscriminately. We only want to append if it's open method. You could do this. Put it through a checker. Put it through a conditional such as this else if statement that checks if it's a closed bracket. Uh, Why is this false? Okay. So it's false because it always appends it and then it always exists. Listen to this. They're trying to check me. I'm not thinking it's just yet. Oh man. Oh, and that's because this. Okay. Now I get it. That's because this executes when it's not empty too. We have to add that check. Oh my god, there's a word by word just like that. Oh my lord.